Have you ever wondered where an aluminum can goes after you throw it away? In reality, very few people realize that a simple aluminum can be recycled into industrial metal wire used in construction, machinery, and mass production. In this video, we will follow the entire aluminum can recycling process, from waste material to finished metal wire, step by step. The recycling process begins with collecting used aluminum cans from waste sites, scrap yards, and recycling facilities. Before recycling can continue, aluminum must be separated from plastics, paper, and other metals. Due to its non-magnetic and lightweight properties, aluminum is commonly sorted using magnetic systems combined with industrial air separation. After sorting, aluminum cans still contain unwanted elements such as paint, ink, adhesive, and liquid residue. If not properly removed, these contaminants will affect the quality of the molten metal. The cans pass through industrial washing systems that use water, mechanical friction, and heat to clean their surfaces. They are then dried completely to remove moisture before entering the shredding stage. Clean aluminum cans are fed into industrial shredders. They are cut, crushed, and torn into thin aluminum fragments. Size reduction allows the metal to melt faster and more evenly inside the furnace. This step also releases trapped air from the cans, reducing the risk of metal splashing during melting. After collection and sorting, aluminum cans are fed directly into an industrial melting furnace. Inside the furnace, the temperature rises to around 660 degrees Celsius, which is the melting point of aluminum. As the temperature increases, the cans lose their original shape and turn into molten metal. During this process, lighter impurities and oxides float to the surface. These impurities are removed to ensure the molten aluminum is clean and suitable for further forming processes. After melting and purification, the aluminum is not drawn into wire immediately. Instead, the molten metal is poured into molds to form billets. These billets are usually long bars or cylindrical shapes that are easier to handle during wire drawing. As molten aluminum fills the mold, controlled cooling allows the metal to solidify gradually. This prevents cracks and ensures a stable internal structure. Before entering the wire drawing stage, aluminum billets are not fed directly into the drawing machines. In the factory, they undergo a controlled reheating process to stabilize the metal's mechanical properties. This step relieves internal stresses formed during casting and cooling. When aluminum is reheated to the appropriate temperature, its internal crystal structure becomes more ductile, allowing it to withstand high tensile forces without cracking or breaking. Although often overlooked, this intermediate stage is critical for ensuring smooth wire drawing and consistent final quality. At the factory, each billet undergoes shape and surface quality inspection. Billets with bending internal voids or surface defects are rejected or reprocessed. Approved billets receive light mechanical treatment, such as turning or surface grinding, to ensure a uniform circular cross-section and precise dimensions. This geometric standardization allows the billet to enter the drawing dies smoothly, reducing friction, minimizing breakage, and ensuring consistent wire quality. After the aluminum billets have cooled and stabilized, they are fed into a specialized wire drawing system where the aluminum is gradually stretched through multiple dies with decreasing diameters. This process is repeated through several cycles to ensure precise wire thickness and uniformity. Throughout the wire drawing stage, the factory continuously monitors tensile strength, ductility, and surface quality, because even a minor deviation can cause the entire wire batch to fail industrial standards. At the same time, the aluminum wire undergoes surface treatment to remove remaining impurities, reduce friction, and improve flexibility. In some cases, mild heat treatment is applied to enhance the internal metal structure, preventing brittleness and cracking during coiling or later industrial use, making this stage critical to the final quality of recycled aluminum wire. Once the aluminum wire meets the required technical specifications, it is guided into an automated coiling system where it is wound into large spools with different sizes and weights depending on its intended use. The entire coiling process is carefully controlled to prevent deformation or weakening of the wire structure after completion. After coiling, the recycled aluminum wire is sorted into specific application categories. Some are used in industrial electrical systems, others in lightweight construction, metal fabrication, or further processing to partially replace steel in applications that require lower weight while maintaining sufficient strength. From aluminum cans that were once considered waste, through a precise and closed-loop industrial process, factories transform them into high-value aluminum wire products, not only reducing production costs, but also significantly lowering energy consumption compared to producing primary aluminum, while minimizing resource extraction and environmental impact. This recycling process demonstrates that metal waste is not an endpoint, but a vital component of a more sustainable industrial production cycle. But the journey of these aluminum wire coils does not end when they leave the factory. Once packaged and transported, they continue into other production lines, becoming part of electrical systems, structural components, or industrial products that we use every day without ever noticing their origin. At some point in the future, these same metal wires may be collected again, melted down, and recycled once more, extending the material life cycle without the need for new resource extraction. This is how a truly sustainable industrial process works. Quietly, consistently, and efficiently. Looking back at the entire process, from discarded aluminum cans to finished metal products, what stands out is not only the machinery or technology, but how humans have learned to extend the value of materials instead of constantly creating and discarding them.